Graph below shows the line y equals 11 minus 11 ninths x, that line right there. A line segment connects the fixed point 8, 9. This is the point over 8 up 9. See it there? Over 8 up 9. Right here. Over 8 up 9, this point right there. And this is that line right there. Okay. With a variable xy. This is some random point on the line. The variable point xy on the line. You can interact with it by clicking the slide. Da da da. Yeah. The question is the length of the line segment in terms of x only, not y, is, and there it is. First off, let me show you the interaction thing. So here, see, you can grab this point down here and move it. And really, what we're interested in doing is finding what is the point on the line closest to that other point that's out there. What's the shortest connection, closest? It'd be right about there, right? See it's 90 degrees, the closest distance 90. See the distance is 4.928. Go this way, it gets bigger. Go there, it's a little small, 4.927, looks like 4.925. There we go. That's about as good as it gets, right about there. That looks like the closest, right? So we're trying to find the X value on the bottom down there that makes it the closest point on the line. What is the closest point on the line? So that's what we're looking for there. So anyway, getting back to the question, how do we find? So we're only going to do the first part. We're just going to do the setup. How do we find the length of this line right here? So what is L of X? What is the length of that line segment? How do we find that? Well, that's we got to use the distance equation between 2 points. And so the distance formula, so this is one thing you'll need to know and have in your notes. The distance between 2 points is the square root of x1 minus x2 squared plus y1 minus y2 squared. That's how you find the distance between 2 points. Yeah, well, here, let me show real quick. Why is that? Well, because if you have some kind of, well, I don't know if it's appropriate to show that right now. Maybe it is. Okay, maybe I'll go down here real quick. I don't know. You can skip this part if you don't want to see it. But real quick, why is that the case? Because if you have a axis system and you have some point here, call it x1, y1, right? It's over x1, it's up y1. And some other point that's out here. Whoops, I thought I switched the color. I did not. Come on, there we go. Some other point that's over here, x2, y2. It's over x2, it's up y2. Then the distance between them, what you can do is you can make a little triangle. I want to show you where that distance formula comes from. Little right triangle. And the bottom distance down here, how far between these two? Well, it's x2 minus x1, right? Like, for example, if this was over 8 and this was over 3, then 8 minus 3, there'd be a gap of 5 between them, right? And then this distance right here, the height of this side. So here, let me put that right here. This is x2 minus x1. And this other side right here is y2 minus y1, right? Because how high up this one is and how high up that one is. Again, if this was 8 and this is 3, the difference between them is 5. So this side is y2 minus y1. This side is x2 minus x1. So, and you remember the Pythagorean theorem, right? A squared plus b squared is c squared whenever you have any right triangle. So this is our c. So then a squared, this side is a and this side is b. So that means x2 minus x1 squared plus y2 minus y1 squared equals c squared. And then how do you solve for c? Root it. So c, and c, by the way, is the distance between those points, isn't it? Right? From this point to this point, a straight line distance is c. What is c? Well, now we see it. It's this. It's the square root of the difference of x squared plus the difference of y squared. That's where that formula comes from. They might say, yeah, but we had x1 first and x2. It doesn't matter because it's square. When you have two things subtracted, the order doesn't matter when you're squaring it. All right, enough said. Back to here. That is the distance formula. Put it in your notes. That's the distance between any 2 points. We'll call, it doesn't matter which one you call which one. We'll call this x1, y1. We'll call this x2, y2. You could reverse it. It doesn't matter. Okay, and so we get the square root of, so this is the distance. The distance between those points, the distance of that line segment. In fact, we should just call it L of x. Yeah, it's just L of x equals, that distance L of x equals. Okay, so what is it? X1 is x right here, minus 8 squared plus y1 is y minus 9 squared, like that. Okay. So now you think, okay, good, we got it. Well, it says it wants it in terms of x only, not y. So we got to plug something in for that y right there. So what are we going to plug in? Well, obviously this equation right here, because when you're on this point, xy is on this line, which means his y coordinate is equal to 11 minus 11 ninths of his x coordinate. That's what it means. When you're on a graph, a line, a curve, any kind of graph, that means in your point on there, that means your x and y coordinates obey the equation of that line or curve or whatever. So that means I can plug right in there for y. In fact, let me do it the other way. I'll plug right in there for y. So the L, the length will equal the square root of x minus 8 squared plus, and then y will be right there, right up here, I should say, 11 minus 11 nines x. Whoops, yeah, I'm a little too quick there. Minus 9 squared, right? So the y becomes all of this, doesn't it? Right? This right here is y. Minus 9. So there it is. And that's the formula they have right there. So that's how you get to, that's a length formula in terms of x only. So that'll tell us at any x value, these are x values down here, right? At any x value, how long the segment will be from the point 89 to any point xy to that particular point with that x value on the line, on this line. And so now this is only the setup. So on another problem, we'll finish this up. We'll take the derivative of this thing and set it equal to 0. Because when you take the derivative and set it equal to 0, you find the min or the max. We can find the minimum, the line that's closest. Find the x value for the line that's closest, the shortest distance between a point and a line. That's how we can find that. This is just the setup. We'll just stop right here. There we go.